Hey guys, welcome. Yeah, so example 2 here, and in this example, I'll get to prove that I was right when I said that there's basically infinitely many interesting problems on infinite geometric series. And here's a really cool problem using infinite geometric series. And the visual pretty much captures what's written, and that is that we have this largest equilateral triangle that has a side length of 4, and then we connect the midpoints of its sides to make the red equilateral triangle, which is second largest. And if you know geometry, it means that the red equilateral triangle will have a side length of 2. And then we connect the midpoints of the sides of the red equilateral triangle to make the purple one. And we proceed in this manner, doing it infinitely. Like so I've showed the yellow and then the black triangle, but it does not terminate this process. We keep doing that. So we connect the midpoints of the sides of the black triangle to form a smaller equilateral triangle. And we do that ad infinitum. So if we do that, which is if we keep this process going for infinity, for an infinite amount of time, then what is the sum of the perimeters of all of the triangles is the question. It sounds like a daunting task, but it's actually a pretty simple task if you have the formula for an infinite geometric series. Because, well, the question again is, what's the sum of the perimeters of all of the triangles? So infinitely many triangles whose perimeters we have to add. But let's start with the largest equilateral triangle. Well, that largest equilateral triangle has a perimeter of 12. Okay? And then we said that the red equilateral triangle will have a side length of 2, so its perimeter will be 6. So far, we've got 12 plus 6. And so you could imagine that the purple equilateral triangle, whose sides will be of length 1, will have a perimeter of 3. So far, we've got 12 plus 6 plus 3. We get the point. The yellow equilateral triangle will have a perimeter of 3 over 2, and so on. So that sum is like this, but it's an infinite sum. Fine. It's an infinite geometric series where the first term, a, is 12, and the common ratio, r, is 1/2. And because r is an absolute value less than 1, because it's 1/2, we can use this S infinity formula for an infinite geometric series. Where a is 12 and r is 1/2. And so if we do that, we gather that the perimeters of all of the infinitely many triangles will add to 24. Isn't that cool? Yeah.